Here's Weird Math Part 2. Okay. So, essentially what this means, 7xd equals x. Also, xd, I found a way to make a smiley face into math. It's hilarious. 7xd. D is divided. Parentheses will make it happen. So, what this means is this x itself is a function of itself equaling itself. So what this means is parentheses change math in a weird way. X. The reason why I put 7 is because I'm going to explain every single one of these using a function, so you know I'm not fucking lying. Also, to explain the last one more so. Also, yeah, to explain the last one more so. What this means is basically required formula for x. This means the whole thing. Required formula. So required 1. Which is the things that go into it, if that makes sense. And the formula as well. It basically has 2 slots. It's this and this. It's required, and then the things that go into it, and then the thing that come out, if that makes sense. So, formula, things that go into it, thing that come out. You don't need that, but you do if you don't want to have to write this every fucking time. So the formula is xd. Formula xd outcome divided. And that is its outcome. So if you use it as a standalone thing, and use this too, it would functionally mean and make 1 equal itself equal itself equal itself. How many times you use to calculate it? So 1 equals 1. X. Imaginary x. But this doesn't have, this isn't the imaginary 1. This is the imaginary 1, but it equals that. But imaginary 1 equals that, and that. They equal each other, but this is divided. So it's divided from this. But so is this, but in both ways. So, imaginary 1 and hyper 1 equal themselves. But each of them equal themselves individually, but they're all different, but they're the same thing. So basically, this is what I mean by individually. The outcome of this. But to put it in simpler terms, this. If that makes sense. Because, there's 2 x's here, which means you can do it again at both points, at both 1 and 1. So you would put 1 and 1, 1 and 1, 1 and 1. But you would also put 1 and 1, 1 and 1, 1 and 1. Does that make sense? But also 1 and 1. 1 and 1 at the same time. And every state, you know what I mean. You only need to do it twice for it to equal a quantum mechanical state. This. However, that is just a singular quantum mechanical state. if that makes sense, which it does, because I proved it using math, mathematically. So this would, well, and yes, you have to use this even though it's a function in fucking calculating things with math in computers. But you have to use it. So we are in a simulation. But not at the same time if we're just individualized. Which is this. So this would equal lowercase q because that makes sense. And to specify which one, I'm going to add one right here, which is 8, which is lowercase q 1, if that makes sense, because it does, so it makes sense. So I explained 3 of these new positional exponent-esque things using math we already have. You are welcome, scientists and mathematicians. Oh, a number file? Please.